Assalamualaikum to Miss Siti Aisyah. We are from Group 6 that present about evaluating student sleep quality via sampling distribution. So today I am Fatin Hasmira binti Yaakob, CN240398, that present the part of introduction. Sleep quality is a critical factor in student physical and mental performance, yet it is often overlooked. While sleep deprivation is widely discussed in academic circles, there is a significant lack of class-specific data that provide a clear picture how sleep quality is actually distributed among the student. Uh, without this data, we risk making the inaccurate assumption about the student health and may fail to implement effective measures against the academic burnout. Our study addressed this by moving beyond personal evidence to provide the statistical proof of sleep trends. We treat sleep quality as a numeric variable and apply the CLT, which is Central Limit Theorem, to analyze its sampling distribution. So, by evaluating the means of multiple samples, we can draw more accurate conclusion about the student population as a whole. So, to guide our research, we have established three main objectives. At first, we aim to identify the frequency and mean sleep quality rating from our collected sample data. Second, we will determine the behavior of the sampling distribution in terms of normality and standard error. And finally, we will estimate the probability that the average sleep quality of a student group exceeds a specific threshold, such as a rating of 3.0. So let's move to the next part.
Hi, my name is Nikno Sabrina binti Paiman. My metric number is 240147. I will present about methodology part of our study on sleep quality rating for students. We grab secondary data from Kaggle and organize the rating into a frequency table to run some probability calculation. For data collection, we got data from Kaggle, focusing on student sleep quality ratings like on a numeric scale. This secondary data was already there, so no need for new survey. We just put a sample big enough to show the distribution properly. Next, we turn that raw data into a frequency table. This group the rating by how often each score show up, helping us see the spread and turn count into probabilities. Super simple way to handle it. Next, I will talk about the method we use for calculation in section 2.2. This part show how we figure out probabilities and key stats from the sleep quality rating data. Calculation probabilities, we took the frequency data and turned it into a probability distribution for each sleep quality rating, which is our random variable. This let us see the chance of getting each rating value based on how often it show up. Here are the equation. The mean tells us the average sleep quality we expect from student. We also work out the variance to check variability in sleep quality. This measure how much the rating spread out from the average, helping describe consistency among students. That's all. Thank you.
Hi, Assalamualaikum everyone. My name is Siti Nur Fatiha binti Roli. My matrix number is CN240193. So, today I would like to present the frequency distribution and probability distribution of sleep quality among 30 respondents, which is shown in Table 1 and Table 2. For Table 1, sleep quality was measured using a 5-point scale, where 1 represents very poor sleep quality and 5 represent excellent sleep quality. From the data, we can see that 2 respondents rated their sleep quality as very poor, 10 respondents reported poor sleep quality, 11 respondents indicated moderate sleep quality, 4 respondents experienced good sleep quality, and 3 respondents reported excellent sleep quality. This shows that the majority of respondents rated their sleep quality as moderate to poor, with moderate sleep quality being the most common rating. Overall, the data gives us a clear picture that most respondents are experiencing average to low sleep quality. So next, table 2 present the distribution of respondents based on their sleep quality categories along with their corresponding probability values. The probabilities are determined by comparing the frequency of respondents in each category to the total sample size of 30 respondents. This calculation allows the likelihood of each sleep quality level to be clearly represented. From the table, it can be observed which sleep quality category occurs most frequently among the respondents as well as those that are less common. Overall, Table 2 provides a clear statistical overview of sleep quality patterns within the study population. So that's all for the Table 1 and Table 2. Thank you.
Hi and Assalamualaikum everyone. My name is Nurin Shamina binti Muhammad Afizan. My matrix number is CN240359. Today I will present about part 3.3 data variation using mean and standard deviation. Based on the table, we have 5 columns which is rating 1 until 5, frequency for every rating, Px equal x, x multiply Px equal x, and also x power of 2 multiply Px equal x. Based on the table, the computation of the mean and standard deviation for sleep quality among students is shown below. The data collected from 30 students has been summarized in a frequency table and a probability distribution function (PDF) to facilitate the calculation and interpretation of the result. For the application of the PDF concept, these 30 samples are treated as the population for the study. Step 2. Compute mean. Formula mean is the population mean approximately equal to the summation of the product of x and Px equal x. So 0.0667 plus 0.6666 plus 1.1001 plus 0.5332 plus 0.5000, we get the answer 2.8666. And then step 3. Compute standard deviation. The formula of standard deviation is the variance of the distribution is approximately equal to the expected value of x squared minus the square of the mean. So 0.0667 plus 1.3332 plus 3.3003 plus 2.1328 plus 2.5000 minus bracket 2.8666 bracket square, we get the answer 1.1156. And from the answer, we square root of the variant 1.1156, we get the answer 1.0562. For step 4, compute sample mean. Sample mean equal to mean, which is 2.8666. Step 5, compute sample variance. The formula is the standard deviation divided by the square root of n, which is sample size. So 1.0562 divided by 30, we get the answer 0.1928. Then we write the distribution in normal distribution form. We get that sample mean x, and for normal distribution, bracket mean 2.8666, comma, and the variance 0.1928 power of 2. Step 6, compute probability. What is the probability that the average sleep quality of a group of 30 students is greater than 3.0? The formula is probability bracket z greater than sample mean minus population mean divided by sample variance. The probability that the sample mean from the question is greater than 3.0. So 3.0 minus 2.8666 divided by 0.1928. We get the answer 0.69. The shaded area at bell curve is at the right side. Then we use the scientific calculator, we choose R for the right side, and we get the answer 0.2451. So that's all from me. Thank you.
Assalamualaikum, my name is Amir Izzati. My matrix number is CN240451. Based on the result, the majority of students reported moderate sleep quality with 70% of respondents giving rating of 2 or 3. The mean sleep quality score of 2.87 indicates that overall sleep quality among students is average and below a good level. A standard deviation of 1.06 shows that there are moderate variation in sleep quality among students. In addition, the probability that the average sleep quality exceeds 3.0 is only 0.2451, suggesting that it is unlikely for most student groups to achieve good sleep quality. So overall, this finding indicate that while student sleep quality is not a critical level, it still requires improvement.
So, lastly, conclusion. This project focuses on applying the concept of the sampling distribution of the mean using sleep quality data collected from a sample of 30 respondents. Through this project, the sample data were used to calculate important statistical measures including the population mean, standard deviation, sample mean, sample variance, and standard error, which form the foundation for understanding how sample statistics behave. Overall, this project strengthens understanding of how sampling distribution are used to make statistical inference, showing how sample size, variability, and probability work together in analyzing real-world data. So I think that's all from us. Thank you.